Hello everyone, how are you? I hope you all are doing fine. By the way, if you're just new to this channel, as always, subscribe to my channel if you like my way of teaching. Just hit the like button, okay? It always gives me encourages to make lots of videos like that, okay? So here's us discussing the lesson electricity, right? So in the first part of that lesson, that is electricity, what we actually discussed, we actually started from the concept of what? Surge, right? But before that, we have to understand the concept of the what? What are the things that we are actually going to discuss in this lesson? After that, we actually understand what is charge actually. Then we discuss what is current, right? How we actually can calculate the current. What is the formula of current? It is what? I equal to Q by T. Then we have discussed what is the formula of current. It is what? Ampere. The name Ampere given after the name of the scientist named as what? Andre Marie Ampere, right? Then we also discuss about an instrument named as what? Emitter, right? And we connected that emitter in series, which actually gives us the information how much current is actually flowing to the circuit, right? Then we discuss about what? Potential difference, right? How the potential difference comes into act, right? Again, then we get the formula of calculating potential difference, which gives that V equal to W by Q, where W is the work and Q is the surge, right? Again, after that, we have to calculate or we have to discuss what is the relation between potential difference and current, and that relation is given by one law named as what? Ohm's law. Right? What Ohm's law gives? V is proportional to I. That means the potential difference is directly proportional to the current flowing to the circuit, right? And to remove that proportional sign, we introduce one constant, which is constant for a given material only. It is not an universal constant, which is a constant for a given material. That constant is known as what? Resistance. Okay. Then we discuss the factors on which the resistance actually depends. Okay. Then we get one more proportionality sign where we get that R is directly proportional to what? L by A. That means L is the length, A is the area. Again, to remove that proportionality sign, we have to add one more proportionality constant. That proportionality constant is what? Resistivity. And it is expressed by what? Rho, right? That rho, okay, gives us the what? Information how much resistance is actually applied in a circuit. And that rho is constant for a given material. It is different for different materials, right? The rho is high in case of what? Insulators, and it is less in case of what? Conductors, right? So these are the facts. By the way, if you have not watched the last part of the video, okay, so I will give you the link in the description. Do watch that video, then you will actually watch this video, because if you do not watch the first part, you are not going to understand the second part also, because it have links. Okay, so these are the facts. So today we will actually discuss some new things. So let's start the class. Okay, today we will discuss combinations of resistance, right? In the last class, we have discussed what is actually resistance is, right? We get the what? Potential difference. But when we actually discuss the current that is flowing through a circuit, we have to understand that current actually depends on what? The potential difference that is actually applied across the circuit and the resistance. How? Because we get the formula as V equal to IR. Right now, from here, if we calculate the value of current, that is I equal to what? V by R. That means what we can say? That current, if the resistance is constant, directly proportional to a potential difference, and if the voltage is constant, that is the potential difference in a circuit is constant, what you can say? That is current is inversely proportional to resistance. That means these are the two factors on which the current actually depends, right? Whenever you have to discuss about the electricity, that current is the main thing. Okay, so what you can say from here, that current is dependent on two factors. But there are certain things, that there are certain gadgets where the resistances are connected in different combinations. Okay, whenever I have to discuss about the combination of the resistance, there are basically two types of combinations. Okay, first one is known as what? Series combination. Series combination. And the second one is known as what? Parallel combination. Okay, now in the figure you actually observe in the two combinations what series combinations looks like and what is the parallel combinations looks like. Okay, but now we are going to discuss all the two combinations separately and respectively. Okay, first we will start from the what? Series combination of resistance. Then we will check that what are the characteristics of the series combination of resistance. After that we will discuss what are the parallel combination of resistances actually gives us information. Then we will discuss what are the main differences in there. Now, what are the main advantages and disadvantages of the what? Series and parallel connection of the resistances. We will check all the things, but now we will mainly discuss the series combination of the resistance. Okay. First we will discuss what is the series combination of resistances are. Okay. A series combination of resistances looks like this. Okay. Where I have got three resistances, that is R1, R2 and R3. They are actually connected at the end of the other. That means if it is the resistance R1, at the end of this, again one more resistance will be connected, again after that one more resistance will be connected. This is actually connected like that. There is a series connection. Okay, one after the other resistances are actually connected. This is a whole series combination looks like this. Here we have got one emitter which is going to give us the information about the how much current it is actually flowing through the what? Circuit. Again we have connected one voltmeter So which is going to give us the information about the potential difference in volt. Okay, how much potential difference is actually applied in the circuit. Clear? Now, see, whenever you have to do some actually observations regarding the electricity, okay, all the observations are done by the experiments. Okay, since you're in now class 10, maybe you're not going to get that much opportunity to do some kind of experiments based on what? Electricity. So we have to now consider the observations done by the others. Okay, done by the other physicists, done by the other scientists. Okay, who actually done the experiment and then they give us the information. So what we will consider? We will consider the observations based on their experiments. So according to their observations, what we can write, in case of a series combination of the resistances, okay, what actually remain constant is the current. That means if you connect a emitter, okay, independent of its position, that means wherever you connect the emitter, you are going to get the value of the I, that is the current is going to be constant. Or you can write same. Okay, it will remain same current, the current will remain same throughout the circuit. Okay, but in the series connection of the resistance, what is the main different thing? Now what will be different is the potential. Again, this is based on the experiments. If you do it experimentally, you are going to get that. When I was in degree, I did the experiment based on the what? This series connection. What I actually got from the experiment, what I did in the degree level, that across the resistances or across each resistance, potentials are different. Okay, so how we are going to get the information? You have to connect the voltmeter, okay, across the end of each resistances. Then those connections are looks like this. 1 voltmeter, again give 1 voltmeter, again give 1 voltmeter. Okay, so give them name A, B, C, D, E, F, V1, V2, V3. Okay, so whenever you just perform this experiment, what you are going to get? 3 different kind of potential or 3 different kind of potential difference across the each resistances. Okay, so at the end of AB, you are going to get the potential difference as V1. So at the end of CD, you are going to get the potential difference V2, and at the end of E and F, you are going to get the potential difference as V3. But the main fact is, once you calculate the, or once you sum all the 3 potential difference, that means once you add all the 3 potential difference, V1 plus V2 plus V3, you are going to get the potential difference as equal to this one. That is the whole potential difference. That means what you can write? V equal to V1 plus V2 plus V3. Okay, this is one fact in case of a series connection. So what we can say from here, the potential difference in a series connection remain conserved. It is not going to change. Okay, it remains constant, but across the resistances it is different. That is the V1, V2 and V3, but it is not that it is equally distributed in case of the all the 3 resistances. Okay, it is not like that. But once you add the all 3 potential difference, we are going to get the whole potential difference as it is. That means if we apply 20 volt, okay, if in case of 2 volt, it should be what? 10 volt. After that, it should be 8 volt. But if we add 2 volt plus 10 volt plus 8 volt, what you are going to get? You are going to get 20 volt. That's it means. That means what we have got? 20 volt equal to what? 2 plus 10 plus 8 volt. That what this equation actually means. Okay, this is the fact that I'm still discussing about, right? So this is the fact. So what we have got from the series combination, that potential difference, though it is different in across the resistances, but as a whole, whenever we want to sum up them, we're going to get the same potential difference as we applied as from the main source. Okay, so from that we have actually got. Again from here, what we have actually got, that the current is same, that is I is same across the circuit. Okay, across the circuit. Again we have got that whenever you sum up the potential differences, you are going to get the as a whole volt potential difference, right? So we will write V is the potential difference across the circuit, right? Since V and I is same in the whole circuit, okay, so what we can write? Capital R to represent the summation of the or the combination of the whole resistance, that is R equal to what? Resistance across the circuit. So since we have got 3 components, that is I, V and R, now we can use the one law, that is known as what? Ohm's law. So what Ohm's law gives? V equal to IR, right? This is the law that actually explains, that is R is the constant, and if you remove the constant, what is going to be there? V is proportional to I. That is the Ohm's law. If we apply this law in all the 3 potentials, keeping the I constant, is the current constant, and resistance are different. So what we are going to get? We are going to get V1 equal to IR1, right? V2 equal to IR2, and V3 equal to what? IR3. Okay, because since in the whole circuit current I is constant, so what you can write like that, current is constant. So if we put the values of V1, V2 and V3 in this equation, what we are going to get? We are going to get V equal to IR from this equation. I am coming actually IR equal to IR1 plus IR2 plus IR3. Okay, since we can take the common I, and I will be get cancelled out in the both sides, so what will be there? Only R equal to R1 plus R2 plus R3. Okay, that means what you have actually learned, as like that potential difference, whenever you sum up the resistances, that is R1, R2 and R3, when they are connected in series only, the combination is going to give us the what? As a combination of the whole three resistances. Okay, when they are connected in series. Okay, that combination is what? Series combination. So we will represent the equivalent resistance, that is R, as R suffix S equal to R1 plus R2 plus R3. Okay, so from the series combination of resistance, what we have got, when the resistances are connected in series, the equivalent resistance, that is the RS, actually represented by what? R1 plus R2 plus R3. But from this relation, okay, what you can actually understand, the resistances are connected in series, okay, and we have to sum up them, directly sum up them, that is RS equal to R1 plus R2 plus R3. But the fact is, whenever you sum up something, okay, whenever you add something, that is 2 plus 3 plus 4 plus something, if you add it, if you are just going add it up, what you're going to get? You're going to get a big value. That means what you can write from here, the equivalent resistance is going to be higher. Okay, see, if the resistances I consider that R1 equal to what? 30 ohm, R2 equal to what? 20 ohm, and R3 equal to what? 10 ohm. So what will be the equivalent resistance? That is the RS equal to what? R1 plus R2 plus R3. Just add up them. What is going to be the 30, 20, 50, 60? That is the 60 ohm. The equivalent resistance is higher than the what? Each of the resistances. That means 60 is higher than 30, 60 is higher than 20, 60 is higher than what? 10. But it is equivalent to what? Combination of the sum of the what? All the three resistances. So that is the main fact that we can actually understand from the what? Series combination. So what we have to understand from the series combination, that in the series combination of the circuits, current throughout the circuit remains constant, but potential difference across the resistances are different. But the fact is, whenever we add up the potential differences, as a whole, the sum of the potential difference is going to be equal to the equivalent potential difference that is actually applied by what? Source. Okay, then we applied the what? Ohm's law in each case of the resistances. Then we just put the values of potential differences in this equation. Then you get the relation as what? R equal to R1 plus R2 plus R3. Since all the connections are connected in what? Series. So we represent that equivalent resistance as R suffix S. Okay. That is the main concept about the what? Series combination of resistances. Okay. Now we are going to move towards our next combination, that is what? Parallel combination. Now we are going to check what is the main different thing in case of parallel combinations. Okay, this is the parallel combination, what looks like. Okay, so here we are going to discuss what are the main observational thing. Okay, what the scientists and what the physicists actually observe doing the experiment in lab. Okay, what they actually observed, that in parallel combination, the main thing which remain constant is the potential difference. That means what you can write, V is remain same throughout the circuit. Okay, how can we say that? If you connect at the end of the each resistances, give the name terminals as X and Y. Okay, if you connect the one potential difference across the each resistance, you will actually observe that potential difference will remain constant. But here what is going to be different? Here the different thing will be the current, that is the I. Okay, I will be different. But how it is going to be different? Because see, consider one experiment or consider one example. Okay, how the currents are going to be different with an example, we are going to understand that. Okay, so consider you have some toffees in your hand, but you don't know how much toffee you have actually. Okay, then you have to distribute those toffees among 3 boys and girls. Okay, consider that. So since you don't know how much toffees you have in your hand, you just have to what? Distribute randomly. But you are not going to know how much toffees you are going to distribute. You don't know that you are going to what? Distribute equally, because you don't know the amount, right? So you can't distribute equally right now. So what is going to happen? you are going to distribute them randomly. So each boy and each girl is going to get different number of trophies, right? But once you add all the trophies, it is going to be the same as you had. That means what I am saying that across each resistance, the current will be different. Here it will be I1, here it will be I2, here it will be I3. But at the out, when it will remain out of that circuit, what is going to be here? We are going to get the current I. That means what you can write, I equal to I1 plus I2 plus I3. That means this one. That is I equal to I1 plus I2 plus I3. But in case of the series connection, what we have got? It was in case of the potential difference. That is V equal to V1 plus V2 plus V3. But here what is different? I is actually in the place of that potential difference. Here I is different. But the combination of the current at the end of the terminal Y gives us the same current. That is I actually originated from the what? Potential difference. That is the main source. Okay, that means this is the fact. Again, if we apply the what? Ohm's law here, how we have to apply the Ohm's law? We know that Ohm's law gives us what? V equal to IR. But from this, what you can write? I equal to what? V by R. So we will now use that relation. That is I equal to V by R. Here what is constant? V is constant. R is different. I is different. So what you can write? I1 equal to V by R1. Okay. I2 equal to V by R2. And I3 equal to what? V by R3. Quite simple. You just put the all values here. So what is going to be there? I equal to what? V by R. You are going to get from this relation. Okay. So here you are going to get V by R1 plus V by R2 plus V by R3. Okay, when you solve, we are going to get 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay, so this is the combination. Since all the resistors are connected in parallel, we are going to represent it R by RP. That means 1 by RP is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this is the relation, or that is the equation which is going to give us the what? Equivalent resistance. When the resistance are connected in what? Parallel. That's why it is represented by 1 by RP. See, in case of the series combination, what we get the relation as? R equal to this, RS equal to R1 plus R2 plus R3. That is in case of what? Series combination. Here the resistance directly connected or directly sum up or directly added up. So in that case, what actually happened? The resistance or the equivalent resistance increases. But here, what actually happened? I will just write down. This is what? Series. Okay. What in case of parallel? 1 by RP is equal to 1 by R1 plus 1 by R2 plus 1 by R3. That is from the what? Parallel combination. Right? I will just write it down. Parallel. Okay, from the parallel combination, what you can write? 1 by RP is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Simple, right? So from these two relations, from the two equations, from the series connection and from the parallel combination, what you can actually say, in case of the series combination, the equivalent resistance is going to increase. As I told you, that is with an example. Here, what is going to happen? The series, that equivalent resistance that is in the parallel combination is going to decrease because all are connected in what? In reverse. We'll take one example. Okay. Consider R1 equal to what? 4 ohm. R2 equal to what? After that you can consider 6 ohm. And R3 equal to what? 12 ohm. Okay, now we will put all the values here. 1 by R equal to 4, 1 by R equal to 6 and 1 by R3 equal to what? 12. Now what is the LCM? It will be what? 12. Okay, so it will be 3, it will be 2, it will be 1. That means 3 plus 2, 5, 5 plus 1, 6 by 12. But it is the value of 1 by RP, right? We need RP. So what we have to do? We have to reverse in both sides. So what is going to be there? RP is equal to what? 12 by 6. That means what? 2 ohm. Now say 2 ohm is less than 4 ohm. 2 ohm is less than 6 ohm. 2 ohm is less than 12 ohm. Right? So what we have got? The equivalent resistance is going to be decreased and it is going to be small compared to the 3 resistance that is connected in parallel. But what we get from the experiment that we did, or the second example, what we got? The equivalent resistance that we get here is going to be higher than compared to the 3 resistance that is actually present here. That is the main difference between the series and parallel connection. Okay, here in case of parallel connection, the series, that equivalent resistance is going to decrease from the resistance that are connected in parallel, and in case of the series connection, that equivalent resistance is going to increase the three resistance that are connected in series. So that is the main concept about the what? Parallel combination and the series combination. So till now we will discuss two type of combination. That is, one is the what? Parallel combination, and another one is the series combination, where the three resistances are connected differently. In the parallel combinations, this is the combination, and the series combination, it is the combination. So we have actually understood the concept of the what? Equivalent resistance. In case of the series combination, it is going to increase. It is going to, in case of the parallel combination, equivalent resistance is going to decrease. This kind of resistance have kind of disadvantages too. What actually happens in case of the series combination? That in case of the series combination, the current remain constant, right? In case of the series combination, what actually happens? The current remains constant. So what is going to actually happen if we use two electrical gadgets in a single circuit? That means if I, in one end I actually use one bulb, and the other end I actually use one electric kettle. So what is actually going to happen? Since the current remains constant in as a whole in the circuit, what is going to happen? The electric kettle needs different amount of current, and the bulb needs different amount of current. If the current flows, but according to the electrical, if I connect a source which is going to give a higher amount of current, that higher amount of current will be suitable for what? Electric kettle, but it is not going to be suitable for the electrical bulb. So what is going to happen? That electrical bulb is going to get damaged. Right? Again, you can take one more example, that whenever in Diwali you you decorate your house with those fairy lights, right? Where what actually happens? Lots of lights are present in those, and those lights are actually connected in series. So by some means, if one of the light get damaged, what is actually going to happen? The whole line actually get damaged. So that electrician have to come and he have to say which light and which part of that light has got damaged. Once he actually find that light which is get damaged, actually once he solve it, the whole light is going to glow, right? So that is the main disadvantage of the what? Series combination. One simple short damage in one light is going to damage the whole light. Okay, it's not going to glow. But in case of the parallel combination, it is different, because if I consider that I need one actually gadget which need high amount of current, I will connect in here. Again, if I need one more different gadget which needs less amount of current, I will combine here. So as well like that, I can combine many gadgets here. Okay, so which is going to get different amount of currents according to them, or according to their use. So that is the main actually advantage of the parallel combination. It is the main disadvantage, where the I remain constant. It is the main disadvantage of the series combination. And here the I remain what? Changes according to what? Resistances. So it is the main advantage for the parallel combinations. Okay, so all the gadgets, whenever it is connected in a single circuit, and many gadgets are actually used in a single circuit, actually parallel combinations are actually preferred. Okay, so that is the main thing. Okay, now we will move to our next topic. Till now, what we have actually discussed? Till now, we actually discussed lots of things. We have got potential difference. We get the what? Difference between relation between potential difference and the current. Then we get resistances, and then we get what? Combination of the resistances. It's a parallel combination and a series combination. Now the fact is, whenever you connect a supply source, as I am showing in the figure, so what that supply source actually provide? Okay, so whenever there is a source actually connected, first it is going to construct what? Potential difference. Okay, so at the negative terminal, the potential is high. Right? So at the positive terminal, the potential is low. So simply what you can say, that the negative terminal, the energy is going to be high. At the positive terminal, energy is going to be low. So there is a what? Difference of potential energy. And that difference of potential energy actually give us what? Potential difference. And due to that potential difference, there is a flow of what? Charges. Right now? And that charge, when it flows per unit time, gives us what? Current. And the current actually flows from what? What is the conventional direction of the current? From the positive terminal to the negative terminal, which is actually opposite to the flow of the what? Electron. Okay, because electron flows from the what? Negative to positive. That is opposite to electron. That is, if current is flowing in this direction, electron will flow in the opposite direction. Okay, and this is the main actually convenient direction of the current and electron. Okay, so that is the fact. So now, whenever a bulb is really glowing, in my room you can actually observe the light is continuously glowing, right? Light is there, light is present. That means what? That light is coming from what? Bulb, right? Now the fact is, how that bulb is able to glow? Because of the what? Energy. This is the what? Electrical energy present in the circuit. Okay, whenever something have to glow, we need energy. That what is the term of energy? Electrical energy. Since we are dealing with what? Electricity. In electricity, the present actually energy is what? Electrical energy. The fact is, now the question, the main question is that bulb going to use the 100% electrical energy provided by the source? Tell me that. Is it possible for a bulb to use that 100% electrical energy? See, whenever you will move to the higher secondary, you will get what? In theorem, there is a Carnot's theorem. Okay, so what that Carnot theorem actually says that nothing is 100% efficient. That means you can't say or you can't use 100% of something. Okay, so here also that electrical energy provided by the supply source, okay, the bulb that we are going to use or any electrical gadgets that we are going to actually use, not only bulb, you can use those fans, AC, anything you want to use, that gadget is not going to use the 100% of the electrical energy. How you may ask me, sir, how can you say that? If it's not so, you actually light bulb is actually going na, you can actually solve it with an example. Okay, in your home you have bulb, right? So do one thing, first you switch on the bulb. What is going to happen? You just allow the bulb to glow for a certain amount of time, that is for half an hour. After you just switch off that bulb, what is going to happen? If you just try to touch that bulb, what is going to happen? You are going to feel heat at the surface of the bulb. Similar case is going to happen in case of what? Fan, that is continuously rotating in my room because of the summer season. Once I switch off the fan, what is actually going to happen? If I touch the fan, what is going to happen? It is going to give me one heat, or I am gonna feel somewhere heat in the fan. Why that fact is actually happening? What is the main reason? So what we can say from that fact or from that observation, that some of the energy, okay, that is supplied by the source, right, and that source energy comes, I will actually explain you how that energy term actually comes. You can actually prove it from mathematically. Okay, I will actually explain that, don't worry about that. So but till then consider that the some amount of energy is provided by the source, and that energy and some portion of that energy is actually used by the electrical instrument to work. But after that, the remaining energy is used to heat up that instrument or to heat up that gadget, like that bulb and the fan. Again, there are certain instruments which only heat up. Okay, like those electric kettle, those heater, like that iron that you actually use to press the what? Clothes. They only use what? Heat up the instrument. So in that case, what actually happens? The resistors are connected in series. Many resistors are connected in series because we know when the resistors are connected in series, that is the what is the formula of series combination? R is equal to what? R1 plus R2 plus R3. So when it is connected in series, the resistance are connected in series, what actually happens? The equivalent resistance increases, right? So now you may ask me, sir, why if the equivalent resistance increases, the heat up actually increases? Again, you will get that. You will get a formula from where you can say that when the resistance of this whole circuit increases, the heat is going to increase, because there is a direct relation, actually direct proportional relation. But for that, till that, so keep in your mind that whenever the whole resistance increases of the circuit, the heating effect is going to increase. Okay, so that is the main fact. So those instruments which only gives us the heat, what is happening? That all the resistance are connected in the circuit, and through that resistance it is going to give us the heat. So that effect is known as what? Heating effect of electric current. So our topic is what? Heating effect of electric current. What actually happened in this case? So we have to actually use some mathematical relations. Okay, we will consider that in this circuit, one potential limit, that is P, is actually applied. Okay, so for that, what is going to happen? There will be a flow of charges. That is the what? Charge is known as what? Q. Okay, so we will consider that charge is actually flowing for a certain amount of time T. Right, small t, time t, right? So whenever there is a flow of charges and whenever there is a flow of the electrons, that means, so when they flow, that means there is a what? Change of position of the electrons, right now. So whenever there is a change of the position of the electrons by an application of force, you will actually understand what is the force actually. So whenever there is a flow of charges with force, we can say it has done some amount of work, right? Again, since there is a presence of potential difference, how we get the potential difference? What is the formula of the potential difference? That is V equal to what? W by Q. That means the work done by a unit charge. That means if there are lots of charges actually present, if there is a presence of 6 into 10 to the power what? 18 terms of electrons are present in the circuit, okay, in 1 coulomb of charge. That means in 1 coulomb of charge, how many electrons are actually present? 6 into 10 to the power 8. 6 into 10 to the power 18 electrons are present in a circuit for 1 coulomb of charge. So what I will say that one charge, if we do a amount of W, that amount of work done is considered as a potential difference. From here, what you can write? That work done will be what? VQ. So what is the formula of the work done here? Work done equal to VQ. Again, what you consider that whole process is contain time T. So if we consider that if this is the amount of work done, which is actually keep doing for time T, so we are going to get one new term for that. But before that, we have to understand one thing. from the concept of class 9 science, you get a relation of what? Work and energy. From that thing, what you have got the, what is energy? What's the main definition of energy? We have to say that the main definition of energy is nothing but what? The amount of work done. So what we can say, the electrical energy that we are actually discussing till then. So what is that electrical energy is considered as the amount of work done, that is equal to what? VQ. So what you can write? Energy equal to what? VQ. Because we know energy is nothing but what? Amount of work done. Here what is the amount of work done? VQ. So the energy will be equal to what? VQ. But if this amount of energy is keep on doing for an amount of time t, that means then we are going to get one new term. That new term is known as what? Power. That means what? You can write power as power P equal to what? Energy by time. Now what is the energy here? VQ. Now what is the time here? T. Again we know now that Q by T is known as what? Current. So what you can write here? Vi. That means what? The relation we have got? P equal to Vi. Right? Again from this relation we can also write contain this and this. We can write that VQ is equal to what? P into T. If we just do some cross multiplication here and here, what we are going to get? VQ equal to P into T. And what is that VQ? VQ is nothing but what? Energy. Okay, this is the energy. Okay, and this energy is not the electrical energy here, and this is the energy which is actually dissipated as a heat. Okay, the amount of heat energy that when a bulb is actually glowing, the amount of heat that we got is actually that amount of energy that is known as what? E. Again, we know heat is a form of energy. So now we can actually represent that E by what? H. Right? We always represent heat by what? H. So H equal to what? P into T. And what we have got? P equal to Vi. So what will be there? VIT. So that is the main formula of heat generation in a circuit. That is the H equal to what? VIT. Okay, so that is the main relation we can actually get. But if you know what is the potential difference present in the circuit, okay, and what is the resistance present in the circuit, so from the concept of from the value of the potential difference and the resistance, what you can calculate? Current I. That means I equal to what? V by R. If you know the value of I, you can actually put and you can actually arrange this relation in a different way. How? We know from the concept of the potential Ohm's law, what do you know? V equal to IR. Right now? You can put the value of V here only if you know the value of I. Okay? Then you can only put down the value of I here, because when you have to calculate the heat, you have to put the value of I now. So only you can actually convert that relation to we can actually convert the relation by putting the value of V only if you know the value of I. So now what will be the relation then? V equal to, we can actually put the value of V here as IR into IT. So two I's are present, so what will be there? I square RT. Okay, it should be H actually. H equal to what? I square RT. So that is the main heating effect law. Okay, that is the main law given by what? James Joule. So that law is known as what? Joules law of heating. So what this law is known as what? Joules law of heating. Okay. So if there is a question where current is given, R is given, T is given, then you can actually calculate using this law how much heat is actually generated. Again, in some cases, if the potential difference current and what? T is actually given, you can actually use this law. Again, use this formula. All the formulas are same. They are not different formulas. You can just actually modify it. So if you remember only one of the two formulas, you can actually convert it to another form. Okay. So simple as like that. If you have to calculate the resistance, if the heat and current and time is actually given, you can as well as you can actually modify it. Okay. So that is the main concept. Okay. Again, whenever I was discussing these all the things, what we have got? We got one more important fact, that power. That is power equal to what? P equal to Vi. Right. Again, we can actually apply the Ohm's law here too. That is P equal to what? V equal to IR into I. That means I square R. So that is the formula of power is equal to what? P equal to higher. This is one important formula, this is one important formula, and this is one important formula. You have to remember all the three formulas. Okay, if you remember this formula too, you can actually write all the things, right? So if you remember one of the two formulas that is the actually represented by H, you can actually convert all the things. Okay, you have to solve you will be able to solve all the mathematical problems that we are going to get in this lesson. Okay, where you have to discuss about the what power, heat, all like that, and Joules law of heating too. So these are the three main formulas where you have got a power, which is known as what, I square R, and here heating effect, it is law of Joule. How much heat is going to be generated? Joule. Okay, because heat is nothing but what, energy, and what is the unit of energy? Joule. So here the unit of heat is going to be what, Joule. Here the power unit is different, it is a watt. Okay, we always consider the power of unit of power as what, watt. We will understand the whole concept of the what, power. Then we got the heat, right? Then we got the what, Joules law of heating. So all the things we have to discuss. Now that Joules law of heating we actually use in general our day-to-day life too. So you have actually observed certain bulbs where the filaments are actually present right now. So what actually that filament is made of? Tungsten. Okay, that tungsten is actually capable of taking high amount of heat. Okay, once it gets some required amount of heat or high amount of heat, it actually glows. Then the whole bulb actually glow. Okay, with the rise of temperature or the rise of what current. So just clearly observe. Okay, from this relation, that is what we have got from this relation, that H equal to I square RT. Okay, we got this relation now. So if you clearly observe this relation, if resistance and time for a circuit is constant, that heat is directly proportional to what, I square. Okay, again if I and T remain constant, heat is directly proportional to what, resistance 2. Okay, if other thing remains constant, okay, again heat is directly proportional to time 2. That means what you can say from that fact, that is H is proportional to T, means if we are giving surges across the circuit for a long period of time, that means what, there will be the formation of the current too for a longer period of time. If there is a formation of a longer period of time, okay, so what is going to be, there will be heat generation. Okay, if you glow a bulb or if you just switch on the bulb for 1 minute of time, it is not going to give that amount of heat. But if you switch on the bulb and keep it like that for 1 or 2 hours, what is going to happen, it is going to heat up more, right, like that. So whenever you use a light for a longer period of time, what is happening, it gets damaged. Okay, so that is the main relation. So we can actually understand from this concept, that is a proportionality concept. So what we can say, whenever in a bulb we use the tungsten filament, right, if current increases, what is going to happen, the heat is going to increase. So once the heat increases, the tungsten filament starts to glow. But the fact is, why we use the tungsten? Because the main fact is tungsten have a high melting point. It is almost 3380 degrees Celsius. Okay, that is the main fact why you use the tungsten filament. Again, it is one more fact, once you get the decent amount of heat, it starts to glow. Then it gives us what, glowingness that we need actually, right, from a bulb. So that is the main fact, right? Again, in some cases we use fuse. What is the main case? We use fuse. Okay, we have to explain it. Wait for a minute. See, whenever you have to discuss about the fuse, you have to understand that in that case of fuse, the fuse somewhat looks like this. Okay, it somewhat looks like this. So inside that there is a wire, and that wire is made up of what, copper, aluminum, okay, and copper, aluminum, etc. So copper, aluminum, those all the materials have actually less amount of melting point. So when there is a flow of the high amount of current, what is going to happen, there is the generation of heat. So once the heat generated, that wire get damaged, and that damaged wire actually benefit us actually. Okay, it has some benefits to us, because see, we all know we use what, TV. Okay, consider this is a TV. Okay, and from this direction current is actually coming. Okay, it is in a circuit. Consider this is a circuit and this is a power supply. The TV is connected and I am just showing the circuit as a thoroughly I am just showing it. So if there is a flow of surge or flow of current, then the TV will actually what, on, it will keep on. But somewhat if high amount of current actually come in a circuit which is not necessary for the TV, what is going to happen, it is going to get damaged. Okay, so in that case we use a what, fuse, which is connected in series. That means we will connect a fuse here. It will what, it is fuse. It is a what, copper wire or anything what, aluminum wire. So whenever a high amount of current actually comes, what is going to happen, the heat is going to increase because heat is directly proportional to current. So whenever that heat actually increase, that wire which is having low melting point, what is going to be, that wire is going to melt down. So the copper wire, that fuse will somewhat remains like that. There will be no wire to flow this charge. So what is going to happen? The circuit becomes discontinuous like that. Okay, the TV is not going to on, but it is not going to damage. Okay, it will switch off, but it will save from the damage. Okay, that's why we use fuse. Whenever you use some kind of inverters or like that, if there is a what we say a 440, okay, so today 440 happened, that's why some instrument get damaged. Those instruments who doesn't have fuse, they actually get damaged, but those instruments or those gases which are having fuse, they keep safe because the fuse get damaged but the instrument remains safe. There is a main use of the what? Joules law of heating in the two cases. Once we actually allow the material to get melt up, which actually keeps gases safe, and in other cases it is the electric bulb where what you do, we actually use the melting point, high melting point filaments, that is known as made out of tungsten. We use or we let the bulb to get more heated up. Once it gets more heated up, the bulb is going to glow. So that is the main actually concept of what? Heating effect of current or Joules law of heating. So this is our last topic of this lesson. So here our main theoretical part is actually complete. Okay, this is our today's quiz question. Okay, and that question is actually perhaps showing one actually circuit diagram where the resistors are actually connected in a combination method, and all the resistors are actually given R1 equal to 10 ohm, R2 equal to 3 ohm, and R3 equal to 5 ohm. Okay, so you have to calculate the equivalent resistance first, then you have to calculate the voltage source. So what is the voltage we are going to get from the source, right? So you just have to calculate that. But this time the quiz question is a little bit different. Okay, now last class in class 9 I have actually conducted a quiz like that. So here for class 10 students also, I am going to only consider 3 winners. Okay, the first person who is going to give me the correct answer, it will be considered the first winner, after the second and third. But if you give the answer at the first position, but if your answer is wrong, you will be actually cancelled out as from the winners list. So first what you have to do, you just watch the video. You first actually clear the concept regarding the series combination, parallel combination. Then after that, heating effect of current and Joules law of heating, all you just clear your concept, then try to answer this question. Okay, without watching this, if you are just giving me the answer, your answer is going to be wrong because you have to observe the circuit first very properly. Okay, so that is the fact. So you just watch the actually figure properly, but I have to give one thing actually. It does actually yes, the arrow marks will actually express what is the direction of the current. Okay, so it will help you. So do watch the video properly and then give me the answer of the quiz competition, and the first 3 winners is going to be what? Going to be as a recorded as a what? First, second, third winner. And for the winners, this time there will be actually presence of present. I will still provide you gifts. Okay, so all the 3 winners. So for that, what you have to do, you have to watch the video properly, then give me the answers. Okay, so be specific with this video and be serious with this lesson because you are going to need this lesson, as I told you earlier, in the higher secondary second year. So you just have to watch the video properly. If you do not skip, if you just skip this part, if you think that I will actually try to understand the higher secondary part, it's not going to work. The basic thing is not going to be taught in the higher secondary. That higher secondary teacher will think that you have actually cleared your basic concept. After that, they will start from a tough concept. Okay, so it is your time. You just have to clear your concept in this class 10. After that, you can actually move freely. Okay, if you get further doubts are there, just ask me in my comment section. I will actually clear your doubts. Okay, don't worry about that. So this is the end of today's class. Okay, so till then, if you have liked the video for whatsoever reason, hit the like button and again subscribe to this channel if you have not done it yet. Okay, so I will meet you in the next video. Okay, till then, stay safe, stay healthy. Bye bye.